Okay, we have this variable. Just gonna check it a little bit here. We have gender, age, level of study, work experience, and department. Okay, and then we also have factors, RA, TMS, government support. There is a variable name, and we can also find it here in our SPSS. RA1, RA2, RA3. Okay, and so on until this one. IFI. The professor today. Okay. So basically, it's just showing you the variable that we have in SPSS. Okay. I believe the next file, this table is gonna be empty, right? So we need to do descriptive statistics of samples for gender, age, level of study, work experience, department, but this area is gonna be empty. As far as I remember, the professor will delete this. So we need to find it where we can find the output from SPSS. So in SPSS, check the variable first. Here we have values. We have the name of our variables and values, right? So in gender, we should state our value. So what is 1, what is 2? Okay, let's see in the data view first. Okay, gender, the data is only 2, 1, 2, 2, 2, 2, 2. But we don't know which one is male, which one is female, right? We don't know. So, according to this data, we check again here. 1 is male and 2 is female. Now we need to tell the SPSS that 1 is male and 2 is female. We go to variable view, and then in gender, we're gonna click this one and create the value labels. So value 1 is male, and then click add.
It's already.
It's already?
Yeah.
Okay, then that's good. It is already there? Okay, that's good, that's good. If the next file there is no values, that's the way. Okay, now we're gonna find out to get the output, the frequency and ratio. We're gonna go to analyze, go to descriptive statistics, and then frequencies. Okay, now we put gender, age, level of study, work experience, and department to the right side. Yeah, analyze. Okay. Can do it one more time. Analyze, descriptive statistics, and then click the frequencies.
Yeah.
Okay. I'm gonna move all of the variable that we want to have the frequencies. We can check one more time. What is it? Gender, age, level of study, work experience, and department. Okay, gender, age, level of study. Okay, everything's good. Block everything, and then click this one. Then they're gonna move the variable on the right side. And then as far as I remember, I just gonna click OK. Okay. You guys get this output?
Yeah.
Okay, now this is gender, valid, male and female. Here's a frequency, and then there's percentage here. These two number, this two number is the one that we gonna put in our answer sheet here. frequency and ratio. So
Come again.
yeah, ratio and frequency. So frequency is here, frequency. But ratio, it just have a different name, but this one is percentage. Yeah. So that's for gender, but if we scroll down, there's age, there is level of study. So same thing. We're just gonna copy like this. Control C. What is this? Level of study. Okay. I hope it's working. I hope. Nope, it's not working. Okay, I'm gonna open Excel. It's easier to copy paste Excel and then go to the Word again. Okay, we got this number and then copy to here. Yeah.
Now repeat that one.
Okay, so after we get the result here, we have a lot of variable, right? The first one is gender. Okay, I'm gonna do the gender. To copy, you can right click. There is copy. Yeah, for gender. Click copy, and then open your Excel. Just a blank workbook is okay. And then paste it anywhere that you want. It's fine. You will get your gender here in Excel already. But I'm gonna just copy these two columns and two rows. Block everything and then Control C. And then go to the Word again. Block everything for the gender. Control V. It's gonna paste.
There you paste again.
Yeah, paste again.
But there are some values. You want it? Yes.
There's already this value there, right?
Okay, he brought it.
Yeah. So
Tomorrow?
tomorrow he gonna give you the blank one
Oh.
with the new data. So yeah, tomorrow I think that's what happened with our bets as well. So tomorrow, yeah, I hope you guys can do it. Okay, that's how you get the result, the output from SPSS. Okay, so far everything's okay? Everything's clear?
Yeah. So you paste the gender and the age.
Age, okay.
Study.
Level of study, yeah. Do you want me to try it for age?
Okay,
So actually there's two ways to copy. I prefer this one. Double click and then you can just select this one. And then Control C. Yeah, double click. And then it shows something like formatting toolbar. Then I can only select the data that I want. Control C. And put anywhere that you want. Control V. And you got the data. Control C again. And move to your Word. Here I'm gonna block for everything on H. Control V. There you got it. So there's several ways to copy. It's okay. Just the one that you prefer.
That's the copy works.
Hmm?
Type in
Okay. Yeah. You can ask. I can wait. No problem. No problem. But professor cannot wait, right? He's always fast. Yeah. It's recorded. It's recorded. I can subscribe. Okay. Next. Oh, maybe this one total. Uh, is all over it here. It's the same total. All of them are the same. Just copy paste. It's okay. Okay. We're gonna move to the next direction. Yeah. Direction 2. Testify validity test and reliability test of main factors. Okay. Okay. How am I gonna explain this? Okay, let's go here. Okay, so the next thing we're gonna do what we call validity test and reliability test. So validity test is like this factor, relative advantage, right? It's one factor, but actually when you do thesis or research, these factors has several questions, like 5 questions or 6 questions, it's up to you, or 3 questions. But at some point, this variable need to be validly explain the factors. Did you get me? Did you get it? Okay. So they have 5 questions here, right? 5 items for relative advantage. In this test, we're gonna see if it's valid or not valid.
Okay.
To explain the factor, to explain the relative advantage. Yeah, that's the validity. So we need to test every variable that we have. If it's okay if we combining as a one factor. Okay, so we're gonna do it here in SPSS. Tomorrow you guys gonna get empty. It's gonna be all of no number. Okay, so we're gonna open our SPSS. We're gonna go again to analyze and dimension reduction. Thank you for whispering me. Okay, I'm gonna reset. Okay, now we put this item, all of this item. This is the question that been answered by the people. To explain, okay, RA1 until 5 is to explain the factor relative of advantage. TMS like top management support. GS, I don't know GS, I forgot.
Government support.
Government support. PU, perceive of usefulness. PU, perceive ease of use.
Yeah.
PV, what is it? Okay. Okay, and so on. So we're gonna put every items to the right side.
So that one is analyze and which means
Oh, okay. Analyze, dimension reduction, and then factor. Yeah, up to IA. So you can check in your yeah, here. And so we have these factors, right?
Yes.
So we only put the variable RA1 until IA5. That's it here. Okay. Actually, everything is written in here, like factor analysis. So where's factor analysis? Analyze, dimension reduction, and factor. This is factor analysis.
What is the selection variable?
Hmm?
The second.
Oh, the selection variable, we're gonna leave it empty.
So why?
Okay, we're gonna see the option here. Okay, block everything. Put it on the right side on the variables, and then here's the extraction method. Actually, professor give you the what we call settings for our factor analysis. Okay, first one is principal components. We're gonna check it. Apparently not here. Here, principal component. Okay, this one is check. Okay, one by one. Rotation method, varimax. We're gonna close it. Rotation. We need to tick varimax here. Okay, then click continue. What is the next one? Extract eigenvalue greater than 1. Okay, actually it's an on extraction again. Here. Based on eigenvalue greater than 1. So it's already set. Click continue. What is the next one? Only indicate 0.5 or more of factor loading values. Okay. We're gonna go to options. And then we're gonna suppress small coefficient and make it 0.5. Okay, continue. And then next step is click OK. Everything's good? A little bit faster? Okay, one more time. It's okay. Okay, we're gonna go again, start from the document. So we gotta do factor analysis, and this is our settings for our factor analysis. That's the only thing that you need to see from the answer sheet. Okay, now we go to the SPSS, click analyze. So where is the factor analysis? Here in dimension reduction, there is factor. When we click, it shows here factor analysis. Okay, and then we need to put all of our factor items from RA to IA5. So the way that I do, just click the first one and then hold shift and click to the last one, and everything's gonna be blocked. And put on the right side. Now we're gonna see every option that professor gave for the direction. The first one, principal components, is on extraction. Now we have several, but we're gonna choose principal components. Basically, it always principal components, so you never change this one. Okay, the next one is rotation method, varimax. Okay, we're gonna click continue. Don't forget to click continue. Rotation, here, we're gonna click varimax. Continue. Okay, you guys good? Next one, extract eigenvalue greater than 1. So extraction again. And okay, we need to click extraction on this, what is it, the lower box, that's like extract. And then we want to see that eigenvalue is greater than 1. Yeah, so it's already set, just continue. The last settings that we need to do is only indicate 0.5 or more for the factor loadings. So here. And coefficient display format, suppress small coefficient. Click to 0.5. Then continue. Okay. And then click OK. All right. Okay, you guys have this output?
Yes.
Where's the insertion? Okay. Okay. Okay, from this output, we're gonna see, actually every output is important here. Okay. So we're gonna see here, there's items, right? And then component. It shows that has 7 components here. Okay. In the output, you need to scroll down until you find the rotated matrix, rotated component matrix. Have you find it? Rotated component matrix. Okay. So basically, professor will show you the component already, and then the number is 7. Okay, now we got 8. Some problem here, right? Yeah. So here we need to check again every value inside the cells if it's okay or not. So according to the explanation from professors, every line supposed to only showing 1 in one column. But here RA2 it shows 2 columns, right? It means that it's not valid. Okay, that's the first thing. And then the second things, it only shows 1, but in the same column for all of the items explaining the factors. Okay, for example, for relative advantage, we have 5. So supposed to be all of these 5 in the one line. Okay, in some cases it will show like this. Explain. It's like for example your thesis or my thesis, it shows like this. So we need to delete the items that has two numbers, two numbers in 2 columns, different columns. So but the others items is good. So it's good. It aligns in the same column. It doesn't show anything differently like this. It's really disaster, but this one is good. Okay, the next step, we're gonna redo again, but we're gonna remove the RA2 and RA4. Okay, analyze, dimension reduction, vector. Okay, RA2 and RA4. Okay, we're gonna click RA2 and also control click RA4 and put it on the left side. Okay. And then just to recheck, but usually it doesn't change. Okay, rotation also already very max options 0.5. Okay, that's good. And click OK. Okay, we're gonna scroll down again to the end. Rotated component matrix. Now everything is good. We have 7 components, and everything is just only one number and aligned in the same column for the every items. Okay. Yeah. So it shows that in RA or relative advantage, only 3 questions can explain the relative advantage or validly explain what is the factor of RA. Okay, we're gonna copy. I like to work in Excel first and then just copy everything here in our document. Okay, copy and then paste in your Excel. So we already got the items and component, but here we have commonalities, right? So for commonalities is the first table.
Yeah.
Here, commonalities. We're gonna take the extraction. Copy. Go to the Excel file and paste it here again. But I'm gonna just take the extraction only. It's wrong. It's okay. And then paste it here. Okay, insert. Okay. So in your Excel, you have already a component and then extraction. The other thing that we need to copy is, if you scroll down, we have this eigenvalue, variance, and cumulative variance, right? And also if deleted items comment. Just gonna put array2, array4. Okay, for this number is for the, I forget the table name, but it's here. Total variance explained. Okay, we're gonna take the rotation. Okay.
We'll take the rotation sum.
Some square loadings, yeah. Okay, we're gonna copy everything. Copy and then put it on your Excel. It's quite big. Okay. Right. Okay. So this one. So total is eigenvalue. Yeah, total is eigenvalue. And then variance percentage is variance percentage. And then cumulative is cumulative here. So we're gonna copy. I like to paste here, but I usually do transpose. Transpose, yeah. Then you will get like this. You guys can follow it up? Okay. So far? It's okay? Should we continue or you guys need some time? Continue? Okay. If we see on the answer sheet, we have this Cronbach alpha, right? So we don't have this value yet. So Cronbach alpha is reliability test. It's kind of hard to explain, but it's more like validity test is to test your question, but reliability test is to test your respondent, your answer. So the answer from the people, is it reliable enough or not? We're gonna test it here. Okay, the way to test, we're gonna do as many as we have the factors. So we have 1, 2, 3, 4, 5, 6, 7. Okay, we have 7 factors. We're gonna do it 7 times. Okay, go to SPSS again. We're gonna click Analyze and then Scale. Here, Variability Analysis. Okay. The next steps is we're gonna put, okay, one more time, no problem. Analyze, Scale, and then reliability analysis. So you will get this window, reliability analysis. Okay, the first is RA, right? But we're gonna put RA, not all of them, because only 3 valid, right? So we're gonna input only the valid one. 1, 3, and 5. Now put it on the items. And then click OK. Okay. In the output window, we're gonna have this reliability statistics Cronbach alpha. Now I'm gonna copy. Yeah. Okay. I'm gonna copy everything and put our copied output here on the Excel file. Okay. The way that I'm gonna do, I'm gonna merge. Sorry, I forgot the word. Merge. And copy the value here. Okay. Oh my god. Yeah. Okay. So we're gonna merge for RA and paste the value here. Statistics. Okay. You guys done? Okay, I'm gonna do it one more time with TMS. Analyze, scale, reliability analysis, and put this one back to the left side. For TMS, every question is valid, every variable is valid, so I'm gonna block everything and put it on the right side. Click OK. Okay, now we got this one. Analyze, scale, reliability analysis. Okay. Oh, the mistake after, we're gonna leave it. We're not gonna use it as our analysis because it's not valid, so we remove. Yeah. This also happened in our thesis. When it's not valid, we remove the question. We remove the variable entirely. Okay, put TMS and click OK. Okay, I'm gonna copy again. Put it here. Merge. Copy.
It's not custom. SPSS. The same.
The file is different.
This one. Okay.
It's okay.
Nine six one.
961. Yeah. 961 here, but this one 96099, but it's just roundings. It rounds to 3 decimals. It becomes 961. When we do roundings, we got to round. Oh. There's a button. Yeah. Yeah.
There's a shortcut for rounding off. You can just take this and this.
Ah, right. Thank you. Thank you. Thank you. Yeah. Okay. Okay, let's finish it. The next one is what is it? GS. Okay. Put it back. Click OK. You sure? Oh yeah. Okay. Same, right? Okay, if it's the same and you a little bit worried, check this one. Okay, it's GS. Yeah. And then this one is for TMS. Then merge. Okay. Yeah, it's wrong code.
Start.
No, is it star or hash?
Start.
No, star. The page. Star. Then it's 6. Star. 0, 6. Star.
Oh my god. Okay, right here I'm done. So we have all of this and I just copy paste in the Word. It's kind of fine. Okay, maybe I can put borders. Okay. Okay. But do the video. No, it's recording now.
Oh, okay.
So Professor James will just show us the video.
Yes.
Subscribe.
No, the amount of
Oh, okay.
where is that?
It's stable, but only this part.
Only this.
Only that part.
Professor, please, can you go to the table for the comeback?
Kronbafa.
Yeah, the comeback.
Okay.
Yes. Please, can you scroll down?
Scroll down. Okay, this is.
So, which one do we pick? I'm saying, I don't know.
This one.
This one. Why not this one? Let me check. I don't know what I'm. How many times have you read? This is my last one.
Okay.
This is
Okay, let me click OK. So
Okay.
start from here.
okay. It's this one.
Last one.
Okay, I think I lost the other one in the.
Yeah. Okay. Right. Mm-hmm. Oh, okay. Okay. Same number. That's good. That's good. For this one, we have already used this one, right? Okay, let's do that first. Okay, from here. And copy everything. It's okay.
All of them.
No, maybe somewhere else. Or new sheet. It's okay. Ah, we have this one, right? No, okay. Scroll down. Okay, just copy. Paste it. Okay. The way that I do it. Okay. Sweet. Okay. Block everything from here to here, from total. From total. Yeah. And then click here, right click. Yeah. Okay, right click. Then it's here, transpose. Yeah. I think we copied the wrong one. Okay, let's go back to the SPSS output. Okay, let's check. I think this is 8 items, right? Supposed to be only 7. Here, it's okay. This one is 8. This one. Okay, this one is 7. Okay, we need to copy this one. Same process. Yeah, stable. This is okay. Professor explained to us that we can have several types of thesis. The first one is included system, as I mentioned. The second one is maybe statistical thesis. So if we choose this path, then we need to have
It's possible
it's possible. This is about your system, rating system, coding, programming. Okay. Okay, 7 components. Okay, I will try to explain again. So factor analysis is basically reducing the question becomes some factors. So this algorithm from SPSS, they analyzing which question that can be combined together. Okay, combining together. So in these files, we have information that factor of relative advantage. We have 5 questions. But how we can test it that this 5 question is validly explaining the definition of relative advantage. So how we do it? We do the factor analysis. Okay, so RA, what is the meaning? Relative advantage indicates the degree to which firms perceive benefit deriving from big data. Okay, from this meaning, okay, for example, in our thesis, we're gonna make 5 questions to explain this meaning. Okay, but when we spread it our questionnaire to the people, they're gonna answer, and then the people, the data that we gathered, we need to test it, whether the people understand the question or not, and then they mislead, so the question is not valid. Okay, then we need to remove the invalid question. Okay, in the SPSS, if you realize something, okay, the output is 7, right? Why 7? Because we have 7 factors. Yeah, so we have 7 factors here. Okay, here, 7. 1, 2, 3, 4, 5, 6, 7.
Yes.
Yeah, so the algorithm in SPSS for factor analysis, it indicates that all of our questions have 7 factors, and then they create 7 factors. Okay, the algorithm said, okay, all of these questions have 7 factors, but which one is similar? Which question is similar or have the same understanding? They put it on the same columns. Okay, factor number 1 is this one. They have 5 questions that has similar understanding from the respondents. Then it's GS 1, 2, 3, 4, 5. Okay, through this result, we can see that, okay, our 5 question is good enough and is valid. Then we can confirm that the 5 question that we wrote about GS is okay. But in the case of RA, the first time we run it, we have this one, right? So at some point, the algorithm of SPSS factor analysis indicates there is 8 factors, but we don't need to happen. So we need to find where is the problem. Okay, we find this RA2. They have 2 value in the factor number 6 and factor number 8. But our research designs only allowed in factor number 6. Here, RA. Only RA here. And we don't have the 8 factors.
Yes.
So we need to remove these troublesome factors. We need to remove this one. Okay. So we don't want to be 8 factors or 9 factors. We need to be just 7. Okay, did I answer your question? Or are you getting more confused?
I understand that if we do that to select the good factors, even though we have to take off.
Yeah, we need to take off something.
How we can resolve this? For example, can we find
Like extra or okay.
for example, from 5 to outwards,
Mm-hmm.
for example, it's fatality. Only one. We can how can we go?
Only one factor is. Only one question is valid.
No. 4.
4. Oh, 4. Then we remove one. We only remove one.
The number of the 0.84 has how many? If it's more high, is better variable.
0.8. Oh, this one.
No, the other is 7 factors.
Is it this one?
No, the table that you explained.
Oh, did we create?
Yeah, this numbers 0.8.
Okay.
If you find what it means.
Okay, it has a meaning. Okay, we have relative advantage factor, right? And then we have this score. It means that, I don't know if it's right or wrong, but this is what I understand. It can explain 84% that it can explain the factors. Okay, this question, RA1 actually a question, right? RA1, and then they want to have, does it really explain about RA, relative advantage? And then the score shows, yes, it explained 84%. Okay. We explain? Okay. How am I gonna explain this? Okay, this is I never tried to explain this actually. So RA1, RA3, RA4, they have factor loadings, right? Factor loadings. And then this value indicates how strong it explains your factors. How strong. The bigger is the better. So what is the threshold? Is 0.5. So below 0.5 is not strong. So this value like 0.8, this is like the power of variable RA1 explaining relative advantage. The concept of relative advantage. This one. Explaining this meaning. So this is like the power of how strong this question is explaining your factors. Okay, maybe we can see the question. If you scroll down at the end, we will find the questions. Okay, RA, we have 5 questions, right? So question number 1, using big data will improve the quality of my work. Is it really explaining the RA, relative advantage? By the result of SPSS, yes. So how much the power is 0.848 something. 0.848 something. Just so that you can explain more from the value of factor loadings. Okay. Is it okay, the explanation, or?
I understand.
Okay.
In the community,
Commonalities. I don't really understand about commonalities. Commonalities. The threshold. Let's check the threshold. The professor didn't really explain about commonalities, so my note didn't take it. Okay, maybe next time if we met again, I will try to find what is it. What this number is explaining about the commonalities. Okay, I'll let you guys know. Okay. Anything else? The number that you want to ask? This data is too beautiful. Our thesis is a disaster. Everything is disaster. Okay, for Chroma Alpha, it's at least 0.6. That is good. 0.6. So it should be above 0.6. Then you can say the respondent answer the question reliable enough. Okay. Okay. Okay, this number also important. Cumulative variance at least 60%. This is 89%, which is really good. At least 60. So it should be above 60%. Okay, this is from my note.
You said the reliable at least
Have to be also 0.6. 0.6. 6. Yeah. Chroma Alpha. Yeah.
This is 0.9.
Yeah, so it's good.
0.6.
Above 0.6. Above. So this one is really good. Really, really good. Yeah.
So how do we interpret it?
Okay, actually the aim of this table to testify the validity test and reliability test, for me, last time I just explained the invalid variable. Why is invalid? Because you know that the number is appearing into columns. And then I also explained the Cronbach alpha, that everything is above 0.6. So you just need to write down in the last, here, yeah. Just gonna write Cronbach alpha, and then this component, factor loading is okay. That's it. Okay, should we continue or is there any question? Okay. Okay, direction number 3, analyze the difference between group means and complete the following table with main factors. Okay. Number 1, calculate the mean, give new variable names. Okay. Okay, ANOVA, t-test and ANOVA. Okay, number 1, we need to calculate the means of each factor with their items, right? Okay, this data, actually professor already give. This is the mean. But I believe in the next data, we need to do by our own, this one. Okay, how to do it? After we know the valid items, the valid variables, we need to combine, right? For example, RA1 until RA5, we only have this one, right?
So that means we can delete the
Yeah, we can delete. Yes, we can delete. But I'm just gonna let it stay here. Okay. How to combine? We need to count mean or average of this number. So 7, 7, 6. We need to count the average. So for this example, it's already count 6, 6, 7. So it's the average. Okay. That's how we're gonna combine. Every items becomes the factors. Now we're gonna have the factors. Okay, we're gonna click transform and compute variable. Okay, so the target variable we're gonna name, I'm just gonna put RA. Okay, target variable is the new variable that we're gonna create. Oh my god, wait a second. Oh, it's already RA. Okay. Okay, RA, I'm gonna put underscore. Okay, now let's find the function group. We need to find the average, right, or mean. We're gonna click statistical, and then there is mean here. Double click for the mean. After you double click, it's gonna appearing here. Okay. The next steps, we're gonna put our items inside the bracket. Okay, delete everything. I'm gonna put RA1, comma, RA3, put on the right side, comma, RA5. Okay, then click OK.
So I need is RAM.
Okay, so it's not possible to put underscore at the end. So RA new. Okay, if you finish this one, click OK. So we're not gonna have anything in our output, but something changed in your data set. Now we have this new variable, RA new. Scroll to the end. We create a new variable, which is the average of our 3 items.
So it just automatically generates the new one.
Yeah, automatically generate new one. You need to change this one. Apparently no, close. Just name the name. RA new or yeah, new. Yeah, it's okay. So SPSS can run if the underscore. Okay. Everything's fine.
Oh, okay, then increases for all the factors.
Yeah, we have 7 factors, right? We need to do it 7 times. 7 times. Yeah, I like this one.
Oh, okay. Okay. Alright, so now we'll change the mean.
Okay. I'm gonna try another factors. I'm gonna transform. Compute variables. Okay, we're gonna just change this one.
Yeah.
Yeah, we don't need to redo everything. Just delete. Put everything. TMS1, comma. TMS2, comma. TMS3, comma. TMS4, comma. TMS5. But you need to change the target variable name.
The name.
Yeah. TMS new. And click OK. Okay, skip. Yeah, here. Now I have 2 already.
Yes. Transform complete variable.
Yes.
Okay.
Okay. Okay, okay. Okay, continue with the for every factors. I'm also gonna do it. Yeah, yeah. No,
No, the middle one, the flat one.
Oh.
Yeah, I know, but I'm doing
Yes.
I don't trust. Oh.
Statistic tablets. Oh, it's good. Where are you from? It's alright. Yeah, I'm busy.
Okay, thank you. Oh. Yeah, there is hot water.
Here. No? No, sir? You come up with
No, it's not true. That's again.
no. It doesn't suit your size. Look at your size. You should give me that style.
Can we move? Continue.
You have to change.
Continue, what? Continue.
I'm going to the last one to go.
Tomorrow, they say you are not class tomorrow. Take your time to understand.
Oh,
Yeah.
Just memorize it.
If you don't understand, memorize.
Memorize.
You understand? No.
Memorize.
Just analyze. You cannot understand. I understand. Just a memory. I understand. You cannot understand. I understand. Just memorize.
I will report all of you. It's my best friend.
Okay, you guys done? To compute every variables, every factors. So we gotta continue. Okay, number 1 is done. Number 2 also done. This is give new variable names. That's the one we did all the same time. Number 3 is analyze the test or ANOVA with those new variables. Okay. Number 4 is complete the following tables. So we're gonna do t-test and ANOVA now. And we're gonna fill these tables according to the output from t-test and ANOVA. So I need to explain you a little bit. So we have two types of comparison of means analysis. So now we are doing comparison of means. Comparison means like your data is gathered with several, your data is gathered, but they have groups of genders, right? Like male and female, for this example. So comparison of means, we want to see which one is higher, which one is lower between these groups. Okay. So the differences with t-test and ANOVA, t-test only two groups, like gender here, and then age, only two groups. But how about the more than two? We need to do with ANOVA, like this one, 3 groups, and then 3 groups.
And please, which one is the
Hmm?
Taki?
Taki?
Taki.
Taki?
Yes. What? In ours, he gave us that. He said we can use the Duncan.
Oh, then Kentucky. Yeah. Okay. It's a post analysis. So first we need to do ANOVA.
Okay.
And then there's like post hoc or post analysis with Duncan and Taki. Okay. Let's do it with gender first. That's the easiest one. Because the others we need to do a little bit complicated. Okay, now we're gonna do t-test analyze for gender. Compare means here. And then we click independent sample t-test. Click.
Independence.
Okay. Okay. Next step, we're gonna put all of our new factors that we already calculated before into the test variable. Okay, and then for grouping variable, okay, the first one is gender, right? We're gonna put gender on the grouping variable. Okay. Then we need to define the groups. Group 1 is 1 for male and group 2 is 2 for female. Okay, then click continue. I think I don't need this. Oh yeah. Okay, that's it. We don't need to do something else. It's okay. Just click OK. Okay, one more time. Analyze, compare means, and then independent sample t-test, independent. Okay, now we have this blank windows. On the test variable, we're gonna put our factors. We have the factors already. And then for the grouping variables, I'm gonna put gender here. Gender. Okay, on gender, we need to define the value of the groups. Group number 1, it's gonna be 1, and group number 2 is 2. So 1 for male, 2 for female. And click continue. And then that's it. Click OK. All right.
Let me try and fix it.
Okay.
It's the two million one.
Okay. So this is the output. Yeah, so let's go back to our answer sheet. We have M and SD, right? M is for mean, SD is for standard deviation. Where we can find it? Here, mean and standard deviation. Okay, shows the same number here. Okay, RA is done, TMS is done. I'm gonna put for government support. Government support here. Government support and then mail. Split cells. Wait, there's no. Okay, already 2. Okay, that's for the mean. Then I'm gonna put the standard deviation inside the bracket. This one. Okay. Okay. Mark up to 2 decimals. Mark up 2 decimals. Okay, it's 2 decimals. It's 2. Okay. Like this. And for female, okay. So I have done with the MSD here. Then the next one we need to find the T value. So this is the T value, and we're gonna put the asterisk according to P value. Oh wait, this one already filled, right? Yeah. So I'm gonna for the GS.
Yeah, that.
Okay. For GS, okay, this is the first table. The second table, we're gonna have this independent sample test. We're gonna look for every factors here, and let's see on the GS new.
The T is 1.42.
Okay, so we need to see first the Leventhas here. Leventhas.
Okay.
Okay, in Leventhas, the significance should be okay. If the significant in Leventhas above 0.05 or 0.05, then we're gonna take the first line here for the T. Okay, a moment. In this table, we have two big columns, Leventhas and then T-test. Okay. So actually, the one that we need to copy and paste to our answer sheet, this one, T-test and significant to tail, this column.
Okay.
But there's a lot of number, so we need to pick, right? Every factors, they shows two number of T and significant. So how we gonna choose? We're gonna see at the Leventhas. Okay, if the significant here is above 0.05 or 0.05, we're gonna take the first line. If it's not, we're gonna take this one. For example, the TMS, this one. Okay, one more time. In the independent sample test, the value that we need to copy in our document is this one, T and significant, to tail. But the problem here, every factors have two lines, right? So the aim, we need to choose which line that we need to take. So to choose the line, we need to check for the Leventhas column first. So in this the Leventhas, we're gonna see at the significant level. If the significant level is above 0.05, okay, for example, this one is above 0.05, we're gonna take these two value.
Okay.
But for example, for TMS, apparently this one is below 0.05, right? Then we need to take this one, this number. Am I right? Yeah, right. Yeah. Okay, for GS new, the significant is above 0.05, so we're gonna take this number. Okay, we're gonna round. And oh, for the significant, okay. Okay, before we put the significant value, so Professor Myung-Jin Lee, he didn't put the significant value, but he put asterisks or the star. So how do we know about the stars? The explanation is right here. If the significance to tail for t-test is below 0.05, then 1 stars. But if it's more than 0.01, then we put 2 stars here. Okay, so let's check for the professors. Oh, no, for the output. GS new above 0.05, then we take the second line. The significant is above 0.5, then there is no stars. Yep. So we're just gonna leave it like that. Hmm? This is the t value. Yeah. So the stars only for the below 0.05. If it's above, then we don't need to put any stars. See this below, and then also below. Like this one, it means the significance level is really low. 2 stars. Yes, this one. Yeah. Right.
So in the first variable, as well as
1 stars. Yeah. For RA.
because this is the low
0.5 here.
the significant.
Yeah. And also TMS. This one. 1 star. Yeah. So it's correct. Yeah. Okay, that's for t-test. Okay, I believe for the department, same process. Oh, for the n, I forget to tell you. We can also find this value, n. Here, n. So for GS, oh, same, sorry. Okay, it's gonna be a long process. I'm gonna skip it. And also, this one, also the same process, right? Okay, I'm gonna just show you. Analyze, compare means, independent sample t-test. This is still the same, but we're gonna change the grouping variable to department. Okay, and then define groups. Well, 1 and 2, same.
Hold on.
Okay, and then click OK. We got the N. Copy here. It's not working. Excellent. That's right. It's the best way, at least for me. Okay. I'm gonna try to fill the RA. And then we're gonna next to the ANOVA. Yeah, ANOVA. Okay, ITRA. This is for come on, we need to copy this one first. RA mean for IT 6.357. Okay, for IT, correct. That's 6. For the standard deviation, okay. And then non-IT, Standard deviation. Okay. 5. Then for the t value, okay, we're gonna see for the Levant test is above 0.05, and then we take the first line. First line is 2 point. Okay. Okay, how about the significance level? Oh, what's wrong? It's below 0.05, 0.05. Yeah, so 1 star. Oh, we can do like this. Okay, then you guys keep continue. There's 2 tables, so it's a long process. Oh, this one is different. Yeah, the age. Yeah, age has 5 value, right? But in the table, it's only 2 groups. So we need to cut off. We're gonna group this one, become one group, and this one becomes another group. So we're gonna combine. There are 2 ways. I'm gonna show you the easiest one. Okay, we're gonna go straight to analyze, compare means, independent sample t-test. Okay, we're gonna put age. Okay, analyze. Okay, one more time. Analyze, compare means, independent sample t-test. Yeah, again. So we put back the department and put the age. Okay. In defining groups, age has 4 groups, right?
Yes.
But so the value is 1, 2, 3, 4. So 1, 2 becomes 1, and 3, 4 becomes 2. In the second group. So we can use the cut point. So 1, 2, 3, 4. What is in the middle of 2 and 3? 2.5, right? So we're gonna put 2.5 as our cut point. So the SPSS is gonna divide into 2 in this cut point. Okay. Do you guys get it? Okay. And then click OK. Okay. The output show above the value h above equals 3, or this one 40 to 50, yeah, 4 to 49 and over 50 years, this one, this line, and then below 3 or 1 2 for this one. Okay, so basically the same process. After this, copy paste Okay. Okay, but in the table, on the first line is below 51, and then the age is above 51. Wait a second. I think I made a mistake. Okay. Sorry. It's not 2.5, 3.5. Yeah, yeah. Yes. So this one, the first group, and then this is the second group. Okay. Again, one more. Cancel. Where is the data? Okay. Analyze. Compare means, independent sample to test. Click the grouping variable, define groups. I'm gonna change my cutoff point to 3.5.
Why is
3.5, okay. Where is this? Okay. So this is 1, right?
Yeah.
This is 2. This is 3. And this is 4.
Okay.
Okay. So I want to make this one become 1 groups, but this one in the other groups. So cut point, it needs to be in the middle of 3 and 4.
Yeah.
So we're gonna like cutting the data below 3.5 and above 3.5. So that's why we're gonna put here 3.5 between 3 and 4. If you want to make the group like this, then between 2 and 3, 3.5, 2.5. If you want to make the group like this, first group and then the second group, then 1.5. In the middle of 1 and 2. Yeah. Yes, if you want to make the grouping like this, the yellow is gonna be group number 1, and green group number 2, then between 2 and 3, which is 2.5. But
the value 2.5 was good. It was not, there was no problem.
no. It was we need to have in this table, yeah, over 51. Yeah,
Okay.
that's why I made a mistake. So just be careful, because the professor gonna kill you. Okay. Now we got the value. Why it's only 17? That's okay. Okay, we got this value, and okay, you guys need to a little bit be careful, because in this table, above 51 is the first line, and below 51 is on the second line. But in your table, it's in the other way around. Right? Above 50 is on the second line. This one. But this one in the first line. So when you copy, make sure that you don't make a mistake. Okay. Can we continue to ANOVA? Mm-hmm.
Perhaps you can show them there on the for picking a new variable. 1, 2, 3.
Right. Yes, that one is also good. In ANOVA. I think I will show you in ANOVA. So in group, making a new group, there's 2 ways. The first one that I show you. The second one, we're gonna do it in ANOVA. But in details, you also can do this method. Okay, what is in ANOVA? We have education level, right? Education level. So in education level, we have 3 groups, A, B, C. But A is including the high school, elementary, middle, high. Oh, below high school. Okay, elementary, middle, and high. But we have our data here is elementary, middle, high. So we need to combine this, right? Just gonna mark it yellow. What's the second one? College and then university. Okay, college. Second group. And above university is the third group. Okay. It's 1, 2, 3, 4, 5, 6. Right? So this is the value 1, 2, 3, 4, 5, 6. In the SPSS, we can have new variables with different groupings. So in this group, we have 6, right? Six value 1, 2, 3, 4, 5. But in the new group, it's only three values 1, 2, 3. So imagine this one becomes 1, then this one becomes 1. It's also 1. Then this one 2. Then this one 3. Okay, if we change, all those value becomes like this 1, 1, 2, and 3. Now it's only become only 3 groups, right? So this is what we're gonna do in our SPSS. Click transform, decode into different variables. Then click level of study. So we're gonna get the name of the new variable or the new groupings. Level study new, it's okay. Click change. And then we're gonna define our old and new values here. Okay, we have old and new. So what is the old one? 1, and the new 1. So 1 and 1. And second one is 2 and 1. The old value is 2 and the new one is 1. And the next one 3, and then 4 becomes 2, right? Yeah. 5 becomes 3. 5 becomes 3. Oh, sorry. Thank you. Then click continue. Okay, if everything is done, just click OK. So in your data set, at the last one, we're gonna find this one. Level study new. Okay, this grouping is the one that we're gonna use for the ANOVA. Okay, you guys done? Okay, the next steps is analyze. Same, still, compare means. We're gonna take the ANOVA, one-way ANOVA. Okay, for the dependent list, we're gonna put all of our factors. And then for the factors, we're gonna put this one. Level study, the one that we already created. Okay, if you guys remember, in our answer sheet, we mentioned Duncan and Taki here, right? It's for the ANOVA. So we're gonna click that one for post hoc.
The post hoc is the ANOVA.
Yeah, and ANOVA. Only in ANOVA. Duncan and Taki. Or Skefe. There's three, right? Duncan, Skefe, or Taki. Okay. You can tick all of them, or just this one, or Taki and Duncan. It's okay. I prefer Duncan, actually. Continue. And then option, I'm gonna click descriptive for getting the mean and standard deviation. Click continue. And then click OK. Okay, yeah.
Which one to choose? Which one to choose?
Which character? Oh, vectors, the levels of study.
This one? Oh, okay.
Okay. So dependent lists all of our factors, and for the factors is level study new, post hoc, Taki and Duncan. In option, click descriptive. Click OK. You'll get your result. So we have our mean and standard deviation. We're gonna put it here. Okay, we have n, mean and standard deviation. Oh my god, okay. That's good. One, two, three. 1, 2, 3, okay. Oh my god, it's wrong. Okay, a little too much. Okay. Okay, we got our mean and standard deviation from this table. The next step is we're gonna see the F. So in ANOVA table, we're gonna take this value. Okay, and then the asterisk for the p-value, significant. But this one above 0.005, so there is no asterisk. I believe everything doesn't have any asterisk. Okay, that's good. Okay, so I'm not gonna put any stars here, and then you guys just continue for ANOVA.
You do the analysis of the NOVA.
Oh, redo? Okay, okay. So here, analyze, compare means, sorry. And then click the one-way ANOVA. I'm gonna reset. Okay, we're gonna put all of our factors, our variables, the new one that we already calculated here on the right side, and then put the level study new, the one that we just created to the factors. Yeah. Okay, and then we're gonna see on the option only two, post hoc and options. For post hoc, we're gonna tick Duncan and Taki. Duncan and Taki. So actually, yeah, I only prefer Duncan, but it's okay. Duncan and Taki. And an option descriptive. And then click OK.
Oh, yeah, thank you.
Okay. Okay. So that's the value that you need to copy. And then the next thing is how to interpret, right? So after you finish all of this value, I was only explaining the value with the stars only. So if there's stars, we can conclude that means between two groups, male and females, is different. Is different. And then which one is higher than the others, we can see by the mean. So male for relative advantage factors have higher value than the female. That's it. You can put more sentences, okay, but the main information is that the male and female is different, and then male value is higher than the female on relative advantage. That's the main information that you want to give. Okay, for the ANOVA, same, only the star one. If there is a stars, and then you can explain on relative advantage between these three groups has different value. And then which group is higher than the others? Actually, we need to see on the post hoc. Okay, on the post hoc, this is Taki. Let's see on the Duncan only. Oh my god. Okay, in Duncan there is no significant, there is no stars, so I cannot show you. Okay, I'm gonna do with something else. Oh my god. No, no. I cannot show you
I
the
have the post hot.
the first how?
I did the
Shipping.
yeah,
Yeah, yeah. But I prefer the Duncan. In Duncan, result, if there is a difference, it's gonna show you two columns here. But here, only one column. It means everything is the same value, relatively the same. By the statistics, these three groups, no difference in relative advantage. Even though the mean is different, right? But by the statistics, it's no different. Yeah. Yeah. If it two or three. Okay. If there is three groups, the Duncan and Taki will show you maximum three columns. If all of them are different, but most of the time it's only show two columns, and then each columns will show you which one is the group, which one is different. Okay, maybe I need to show you with another thing. Oh, not this one. This one is significant. Beginner, intermediate, 5, 5, 15. Okay. I should have chosen this one. Okay. Work experience. Work. Oh, what? Okay.
five,
5 into 3, 3, 6 into 3. Okay. All right. Okay. Pass Hawk, then Kentucky, like this. So, let's go back to our output table. Okay. In work experience, for relative advantage, it has stars, right? It means one of this group at least has different value or has different means, mean average. So we need to know which one is different. But by the mean, we cannot judge it for ANOVA. So we need the Duncan Kentucky. So look at this table. For RA, relative advantage, the first one is on the first column, right? And then the number 2 and number 3 in the second column. So group 2 and 3, by statistics, doesn't have different means or average. But for the first group, it has significant difference here. Okay. And then this value is bigger than the first group. Second and third group has bigger value than the first group. And then you write like this. Group B and group C bigger than A. Okay. And then you explain in this table. Okay, this one.
Yeah. I think we are at the surface.
2 lines
We are at the
here. Okay. Okay. In Taki and Duncan, it shows which one is same, which one is different. So the first column here and second column here, right?
Yes.
But on the first column, only the first group number 1. Work experience, group number 1. Or this one, beginner. Okay. And then on the second column, it shows the group number 2 and number 3, right? Which is this one, intermediate and advanced. It means that the first group is different with the second and third group. Second and third is the same, but one is different. Right here. Yeah, there's like 2 groups. Yeah. It's not good or bad. It's just so we can explain that second and third group by this value is higher than this one, right? This is 6.55, 6.57 is higher than 6.04. It means that with the experience of 5 years above, 5 to 15 and above 16, has higher value for relative advantage of big data in work experience rather than higher value rather than the beginner or below 5 years. So work experience above 5 years on relative advantage of big data is have more meaning than the beginner. Yeah, like that. Has more meaning. I think this is about big data, right? Madagascar. Yeah, big data. Okay. Is it okay? You get the point? No? Okay. The 2 columns in the Dun Kentucky. These 2 groups. Okay. There were 3 groups, right? But in this subset alpha column, it's only show 2 columns. Okay. It means every value in the same columns actually same mean. The value of the mean of the average or the average is the same, no difference. Like for this one, for example, group 2 and group 3, the value of the mean, actually this is value of mean, is on the same column, right? So it shows, Duncan and Taki shows that this 2 value is not significant different, really small difference. But it's different with the first column. It's really high difference, 6.0452. Now it's statistically proven by Duncan and Taki. So these 2 columns is showing the only thing that different and same If it's inside the same column, it's the same. But if it's different column, it's different. Like this. It's so complicated. It's okay? You got it? Okay. 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 I hope you guys got it.
Tomorrow, when the quiz comes, quiz kill the quiz. After that, we'll go and have chicken.
Okay.